This is the project 1-8 from the 266 class. So one of the things to notice is that this was drawn in millimeters, grams, and seconds. And if you get a file that has those metric units, then most of the CAM packages will come across and be in metric units. So if you can identify that first, that wasn't what I wanted. We'll get a little closer there. I'm going to switch over to inch, pounds, and seconds. What that also means is that I'm going to end up with some strange numbers. So the 1575, 40 millimeters. All right, but they're just numbers, and the CAM package doesn't really care. And all we need is drawing and tolerance to, are we making it correctly, or is it out of tolerance? So looking at this piece, this is 12 millimeters. So the question would be, do I clamp this down and use a 1/2 inch piece of stock, or do I go oversized, maybe try to find a piece of 5/8? 5/8 not being as readily available in the shop as maybe 3/4. Do I say waste, but do I sacrifice a 1/4 inch of material to hold onto this, and then flip it over and machine the backside? All right, so those are our choices. If I fixture this, I'm going to add time to the to make the fixture, clamp this down, machine whatever portion of it that I can reach, change the clamps over, and machine the other portion so that it's all held in position in the same orientation while it's going through the machine process. How many of these am I going to run? If it's one, okay, I might go ahead and use the universal tooling plate and the clamps and make one, and use the 1/2 inch material and take 10 thousandths off and 10 thousandths off, and be right there. For any kind of production, we may jump up to 5/8 and order 5/8 by, let's see, our width is just shy of 4 inch. So if I could get 5/8 by 4 inch wide, I could sneak that in there. All right, and then I would just have a bar stock that I would be cutting off to whatever 5 or 6 inches, leaving a little bit oversized. So not quite 4 3/4. So I can come up with a bar stock that says I wouldn't be having to recycle as much chips on an 1/8 of an inch as I would with a 1/4 of an inch, but I'm a little bit closer. I'm also now holding on to, instead of a full maybe 1/8 of an inch, I'm holding on to 60 thousandths so that my tool is staying far enough away from the vice jaws. All right, so whether we're given that information and the machine shop manager, the production manager comes in and says, here's your stock program, or we sit down and we just go through that same thought process of, what am I going to pick for material size? And how many are we going to run? Well, first question is, how many are we going to run? Are we running 1, 5, 10, 100, 1,000, 10,000? That's all this part. This part is all that machine is ever going to run in its entire life. Then we are going to make decisions based on that production schedule. Tooling comes into the next place. Do I do this with one? Do I need to make 2 tool changes, 3 tool changes? And we're going to assume aluminum. But if this was 440 stainless, I'm going to make a different set of assumptions. I'm going to make different choices in the tooling and the rigidity of the setup, and just about everything else that we go with. So aluminum is going to be the choice, and then next is, what is the orientation? So when I look at this, I kind of want to put it in the vise, looking down on it this way, so that my x-axis and the fixed jaw of the vise is across the back, and I'll put the work stop on the left. And again, that's out of habit. More so being right-handed, I'm going to pick up the part in my right hand, the wrench for the vise in my left hand. Part gets slid in up to the work stop on the left. I close the vise. Maybe I tap it down with a hammer to seat it onto the parallels. Close the doors, hit cycle start. push the button, watch it go. Part comes out, next part goes in. Next question is, if we're running one, I'm going to set up one vise. We go into the 100 mode, however many vices I can fit on the table, however many work offsets I can utilize, so that before each tool change, it's run 4 parts. Perform a tool change. Run the next operations in 4 parts, and then every time I open the door, I'm taking 4 parts out that I'll have to flip over and face off the backside. All right, so all of that conversation occurs in my head in about 30 seconds, and I make those 20 or 30 decisions very quickly. And if I walk over to the stock rack and I have that material, that discussion's over. I walk over to the tool crib and I have those tools, that discussion's over. If not, what do I need to order? How do I need to get it here? All right, so then I sit down to write the program. We have the model. It's either been provided to us or I've created it. Do I have tolerances? Are there any things that I'm really concerned with? For machining orientation to help out, one of the things that I would like you to start doing, or at least thinking about, is I am going to Alt-Arrow key this into position. And I don't want to do that every time, but this puts it in the looking down framework of I can kind of imagine the vise. If I took this over into the assembly like we did last time, do you want to run it in the assembly? And I need to look and see if I still have my my vise models, but I'll put those up on Canvas for you if you want to build them into the assembly and start building out more in the library. But from a speed portion, simple part like this that isn't necessarily a long production run, I'm just gonna kind of set this up and imagine where the vise is in relation to the part. The process then is to hit the space bar, and I'm going to have a saved view. Oh, sorry, that was this one. Upper row, new view, and usually I just call it a machine orientation, so something like that, machine or. So that is the orientation that I'm going to machine in. And what that does is I rotate around and I see something over here. I hit the space bar. I can get back to that view because it's now a saved and a semi-standard view. Machining from this direction. What am I going to do with these corners? My round tools do not cut square corners. So I go back to the engineer, I go back to the machine shop manager, I go back to the customer, and I say, hey, what's the smallest radius I could put in there and still have the function? Oh no, you can't have a radius. Well, can I overrun the corner and not generate a stress riser? Well, no, we've already done it that way. All right, then I'm going to have to, in the process of coding, or whoever is doing the coding, that we sit down and go through our manufacturing processes. I'm going to run this out, and then I'm going to have to set up another operation to come in and blow out that center section. That leads to the question of, do I just run around the outside as a profile and leave that in place, or do I go ahead and cut most of it out, knowing that this is going to be fairly efficient in a laying flat orientation? When I set it up on end, I'm going to lose that rigidity, and this is going to sing more, so I may lose some finish even as I'm squaring out those corners. Well, I'm going to say you can go put an 1/8 inch radius in there if you want to, or we'll set it up as another operation. So back in
20 of them in the van, no? Last operation.
Yeah, pretty much. Yeah, but even stacking them up, gang milling a group like that, if it's a tight tolerance, and I stack them up, I get a little bit of angle, I get something on there. I'm not sure that I'm going to trust it as much as an individual or even two. So the gang milling is on the table if this is a fairly open tolerance, and I can close it in the vise in such a way that we can get a clamp on it across the span of 10 or 20 parts stacked up without getting some kind of angularity in there or having one fall out of line and shifting. It may be a thing that we can afford to lose one out of every 25 because it's a simple part and it's aluminum. But realistically, we want high production numbers. So as a design for manufacture that we were talking about earlier, if I need to put in an 1/8 inch radius, this is one where I bump the tolerance up to where I have a little bit 5/1000 over, 1/4 inch end mill, 125. Having that little extra puts just a tiny arc in that corner, as opposed to a come to a stop or come to a sharp, change directions and go. All right, it's very minor, but if I have at least that much, I can I can use it to my advantage. All right, so this makes it to where I could potentially machine this with one tool. But is a 1/4 inch tool going to be the most efficient to run this part? Probably not. All right, so if I can blow this out with a 1/2 inch tool, change into a 1/4 inch, and come back and maybe do this relief, I can live with that. I'll get most of my geometry. I'll have a larger radius in here that I have to contend with, but then my 1/4 inch tool can come in and just feed out. All right, so I have a plan. Is it a good plan? Won't know until I get it to the machine and actually start making parts and say cycle time is what the estimate is from the operations and the CAM software, and or no, I missed it. I can't run that fast, or I need to come up with another strategy. To that end, I will give away my favorite. Oops, wrong one. Did not want to hide that. The other thing is, if that needs to be a square corner, it's going to intersect. Then, and I'm allowed to put in the corner reliefs. I like to do a small section, so a 3-point arc. Go back to the end point, drag that out a little ways. All right, rather than just drilling a full hole in that corner, I want my 1/4 inch end mill to be able to just take that little dive in there, or mostly in there. And let's see, we'll put 10/1000 of clearance, and not have to change anything too drastically. So 45. And then we said we're up about 130. We'll set a center line. And all of that gets mirrored. Features, extrude cut, through all. Now, the documentation side is I made this change per a request, a manufacturing request. How do I make sure that this gets back into the engineering documentation? If this is the engineering document, I've just made the change, it was approved, there shouldn't be an issue. But if we have a set of policies and procedures that says I have to submit this, it has to come back, somebody has to enter it, somebody has to approve it, and then it gets back to me, I can't just make this change.
Somebody's got to write a video.
I go through the whole process of getting there. So if I make this change on my own, I may be opening up a can of worms. So I don't make this change on my own.
Would you explain again what is the tool path that allows you to make that is preferable or desirable?
So if this is fitting into a corner, I want to be able to go into the sharp. So the corner of the part that fits in here will go right to that piece. The 1/4 inch end mill will come in. It will remove most of this material depending on how I tell it to do the operation. It gets down into this corner. It'll take just a little zig as opposed to being a full circle and either drilling out the corner and having a complete overrun. To me, this is less of an interference, less of material. From a stress strain, I've taken since I've taken less material out, this is still going to be stronger, less of a stress riser from being a sharp corner, and I've also improved the machining process. I don't have to take a drill and drill out that corner or go into that corner some other way. So I call it kind of a truncated Mickey Mouse here to as opposed to, well, let's go ahead and suppress one more time since we're since I like my corner geometry. A lot of times you'll see that it is quicker, it is easier just to go, let's put in a 1/4 inch tool. We'll put in a 1/4 inch drill, and we'll blow that that hole through. And let's see if I can overlay that sketch on top of it. I probably have, I've left, at least 50, maybe 60% more material. And I have a more efficient toolpath. So I could argue it both ways. If this was a manual operation, yeah, I'm gonna be okay with doing the full corner. Because manual, I can set up a drill and blow those corners out. But when I have access to the CNC, I'm gonna go with the with that truncated. So again, it's one of those. This conversation needs to happen way before we get to this point. When we're doing the initial, either the machine shop manager, the production, when we're looking down through these parts, hey, can I do this? Can I get away with this? This is going to drive decisions that we make in our machine processes further along. All right. So we'll see what the results are. All right, so since that one is erroring because I'm using similar geometry, that can go away. And the absorbed feature is the sketch, so we will delete it as well. And put that in. All right, so we've made some choices. We have 5/8 inch material. I have 472, so I'll probably go ahead and we're going to run the face cut across the top. What did I say was the width? Just shy of 4 inches. Well, we can find a 4-inch or a 5-inch shell mill or face cutter to take one pass on. I'm good with that. We'll load that up. We'll take the 1/2-inch tool, run around the outside, get into the corners. The 1/4-inch tool can come in. The bores then 787. Do I load up a drill or put the 1/2-inch tool into that as a helical spiral? Right? I don't plunge in mills like I would the in mill, but I could set this up in a pretty aggressive helical spiral and blow that material out and finish it as fine as I could with the drill. So 787 plus or minus a thou or two. I'm going to put the in mill in there over picking a drill. All right, one less tool change, one less tool to set up, one less tool to be concerned out with wear. So that's kind of my decision tree. All right, so we have a plan. We're into the operation. All right, so we come over to our HSM tab, set up the new job. All right, and then we went through the process. No additional stock. I'm going to control stock at the machine. All right, so when I set this up, whatever we saw cut, I'm going to measure, and if I find one that's way undersized or way oversized, I'll kick it out to the end. But the majority will be within 10,000ths of each other, so my numbers are going to be fairly nominal. We have, let's see, stock and orientation. That went to the front plane. So origin and orientation. If I set up a coordinate system, then I would have to pick for it. Z-axis and x-axis, that's going to be my preference. If we wanted to pick for z-axis and y, x and y-axis, we could. But what that does is it allows me to select that face. And I think last week on the assignment 1, I got those backwards. So kind of go through and experiment with the different selections there. But I think I use z-axis and x-axis. I've used it for so long that I don't even look at that anymore. It's just one of those settings that's in the background. We picked a face. Then the next one is to pick the x-axis. Shows the direction. And if I reverse that, then my x-axis is going the correct way. And then I will go to model origin, or no, selected point. I want to pick where to place, because model origin down there doesn't help me. It's at the bottom of the part. I want to be at the top of the part with my x-axis going in that direction. That puts it where I want. Okay, so let's see which one will do this. I think these stay modal. Yeah, or they should stay from one job to the next, from one session to the next. We'll find out. If we have a naming scheme for our programs, most of the posts are going to accept a number for the program name, and then we can put the comment P1-8 setup 1. Work offset will stay with G54. When we get out in front of the machine next week, we'll talk about tool change position. Why on the range of machines that G54 is the only work offset that you can touch off tools in, that becomes my tool offset. It becomes reserved for, oh, I broke a tool, I need to touch it off again. I'm going to go back to G54. My operating are G55, G56, G57, 58, however many vices that I have. Go ahead and accept. All right, first operation, I'm right-clicking just kind of out in the area. Other programs, you click on the, well, I guess they changed it. Let's see what changed. Okay, you can click pretty much wherever you want now. So I stand corrected. We're going to do the 2D milling face operation. We talked about last time running back and forth, so this time we're going to set up a 4-inch. We're going to see what we can find for a face mill, and nothing in the list. So let's cancel out of that. Well, let's go ahead and pick a tool. So if I don't have a tool selected, the operation goes away. At that point, I can at least preserve the operation as I've set it up. The 1-inch tool goes in and starts to run. I don't have to, even though I'm at the very start, I haven't just flat kicked that out. So back into the tool library. We have a custom library started, so my tools will go in here. Most all of these folders are going to be set to read-write permissions, so they don't let you change the default. So my library is a right-click, create a new library, and then this will act as the library. So these are my custom tools or a job list or whatever. In here then, let's see, select those, there we go, new mill tool at the bottom left. And we're going to set up for, because I want this to go to the next number in the sequence when I add it, these are all zeros. Numbers, zeros, and these will all line up to 0. And we're going to call this the 4-inch face mill. I don't know how many flutes, probably 6, at least 4. All right, so the cutter, we go over to pick our face mill. Try again. So multi-insert. Flute length, I'm going to stay with their numbers because I'm not looking for interferences. If I have this shell mill in front of me, I can take measurements. What I'm really concerned with is that I get it to 4 inches, and if there's any back angle or whatever that I have an actual, this is what it will take for a pass. I don't want to set this at 4 inches and find out that with the back angle, or what are they calling it here, the taper angle, that I can only cut 3 3/4, and then it ends up that I take the first pass, it doesn't clean up all the way, and then I have to go back and tell it to take 2 passes. All right, so we're going to verify that it will actually take a 4-inch wide pass. Shaft, not a big deal. Holder geometry, feed and speed. If I know that I'm running this pretty consistently, and this may be where I would set up this tool for aluminum in my C2 inserts, or set it up for steel in C5 inserts, one running faster, one running slower. So surface feed per minute, I don't know about 5,000. I might buy 1,000, but still at a 4-inch, 954 is not that, it doesn't seem that fast until you got this thing cranking out in the parts. All right, so don't need 2 decimal places. Don't really need 2 decimal places on the ramp. And then cutting speed, 13 thousandths per tooth. Let's drop that down to 2 thousandths per tooth, but we have 4 teeth, 5 teeth, something like that. And so that's putting me at a cutting speed of about 7. Bump it up at 8. Go ahead and stay with the ramp feed. we're not going to plunge this. So, you know, if it does accidentally plunge for some reason, the slower the better. I want to catch it and watch it try to plunge for a long time before it actually touches material. All right, so these are guesses. You know, I've gone through on my numbers, and we get it out to the machine and say, yeah, that ran fine. Left a beautiful finish, got exactly what I wanted out of it, or no, I overrode it up 10%. I overrode it down 10%. I get some actual numbers. I can come back and feed it in the database. So next time that I see that tool and load that tool, it will have those similar numbers in it. Okay, edit, back to the library, go to my custom. Now I have a tool to select. And, well, it doesn't look like much, but that's pretty much all I need. It looks like a big end mill. All of the numbers that I set in the library came across. I don't have to change anything. All right, so at some point we're going to start building our own library of tools that we use. If it's the side mount tool changer, having a tool crib, the first 8-10 tools already loaded. Carousels don't lend themselves that well, but maybe the same thing as the first 2 or 3 tools are at least common, and we use them over and over again. For a face operation, it's going right to the stock contour, finds its way around. We're not trying to avoid anything or go through. Let's see, 0.2 and 0.8 and 0.2 model top and 0.0. I'm okay with that for the facing mill, the extra 0.2. What this is going to do then is the feed height and the retract height are both going to be, let's go, well, that's not great, but it's pretty good. All right, so feed and retract I don't need to adjust. But if this really what it comes down to, if the feed height was something I wanted to put in the bottom of a pocket as opposed to a slow feed to some additional depth, the retract would always be up here and I could feed to something lower. All right, so that's why there's 2 numbers there. As long as those numbers are the same, we're 200 thousandths above the part, the 0.8 gets added to it, so I will see a clearance height of 1 inch and the retract at 0.2. That's going to give me enough to feed in and be able to work with. Going into the face, full width, I'm going to give it the full 4 inches as a step over so it doesn't try to take a second pass. We're not 0 degrees. We'll see what 0 degrees is. There shouldn't be a pass extension. Stock offset, well, we got a little bit to work with. And we're going to machine both ways, so we'll see what that does. Lead in and entry of 0.4 is above the part. So I'm kind of jumping over the first part, lead in, lead out, smooth transition. Let's see what it generates. All right, so we come in, it has enough to clear getting into the part. Center line of the tool finds the edge of the part, starts leading out. And since it's ramping out, it should be transition. The problem is going to be we're going to have swirl, 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 and then the back swirl is going to be kind of apparent in that last segment. So if I want a consistent finish all the way across, I really need to extend that lead out. So, it would be one of those, we get it out to the machine, we would see it pretty quick. So let's see, if I turn that off, and that was the angle. Oh, there we go. Extend before retract. That was the one I needed. So this one can stay same as lead in. The button extend before retract should bring it all the way across. All right, so now I have a consistent. Okay. The profile then, so I lost my frame of reference. Going to go back into that space bar, get the machining orientation. We click out. That toolpath will go into the background. Next, we'll go ahead and set up for the 1/2 inch tool. 2D milling. Let's go ahead with the 2D contour. And let's see, I want to finish. I'm going to rough, but I want to finish just on this inside pocket with a 1/4" tool. So when the 1/2" tool comes in and blows that out, when it comes back and finishes the outside of the part, I want to jump across that gap. So I'm going to have to lie to it. I need a sketch. All right, so I don't need a sketch right now, but we're going to here in a minute. All right, so tool 3 then, we're into by type, flat end mill, 1/2", and select. All right, so it came up with numbers. I'm going to use this tool again. So I'm going to go back into the library and, oops, I jumped over something. So back into that one. So at this point, if I change these numbers, and I'm going to get a little aggressive on that one, so 1200, I pretty much run the 1/2" tool, 9000. I'm going to stay with the 2000ths. 54 is a little aggressive for the first part, so we'll bump it down to 30. But I'm going to be prepared to move that back up when we get into full production. All right, so what that means is it should take less than a minute to go around the outside of this part and be ready to finish. Following operation uses tool, but with different speeds. Oh, and yes, we want to update and change. Select. There are my more aggressive numbers. Right, so the next operation that I put in will go back to the current library, not to the database library. All right, so where I pulled that tool from, it will come back to this one and it'll reproduce. If I use this number enough, then I'll want to add it to my custom tools or to a machine library. Okay, the model, I'll rotate over a little bit. I would like to start on this corner, probably just out of habit. And I'm not worried about my reliefs in the corners. It's not going to put that 1/2" tool in there. Tangent propagation says find everything that is connected by a radius. Propagate along Z says everything that's connected on that part. If this was an open profile, I could take the propagate off and say just finish that edge. And there's only a little bit of tangent. If I started here, this would be, no, it still comes to a point. There's no smooth transition, so there's no tangent propagation here. If we had radiuses on each of the corners, then we could have tangent propagation. And direction-wise, let's go ahead and highlight the edge again. I thought I saw it, but then I started pushing buttons. I'm looking for the little arrow that should be out there. Let's jump out of it, jump back into it, highlight. Oh, I lost it. It jumped over here. Okay, so wherever it puts the little arrow, I'm now doing the imaginary. My tool is spinning this way, running along that face. I am climb milling, and I am going in the. I'm on the side to actually remove with the stock. So my quick verification. 472 deep on a 1/2" end mill. This is going to be a little bit. This is going to be a little bit tough. All right, especially at 30 inches a minute. Do I want to try it on the first shot? Yeah. I may slow that 30 down to 20, 25, but I also may just be ready on the override, the feed override, and drop it down 10% a couple of times and work it back up as it. The main concern being that going around the outside with 60 thousandths, heavy corner, getting into this pocket, that's a concern. All right, when I turn that corner and I go full width, full depth, that's going to spike the load meter. We're going to see, we're probably going to go from 7, 8, 9%, 30 to 50% right on that first turn. That's acceptable, or run it. All right, so retract heights. I'm not happy with these numbers. I'm okay with the adding. I just want better numbers. So I'm used to seeing 100 thousandths as my retract and feed. From the stock top, well, we set the stock and the model top is the same. From contour, and since I picked the top contour, that's 0. So let's go back and clear the selections. And what I really wanted to do was that contour, because that's going to set the depth automatically. I don't have to pick anything. I just have to tell it that bottom from contour go like an additional, what did I say, 30 thousandths to be able to clean up. And it moved on me, so minus 0.03. And so it takes this cutting plane, this purple-blue cutting plane, and it shifts it down 30 thousandths. Tool now overruns, and I still have my 80, 90 thousandths that I'm holding on to in the vise. All right, so we took maybe 5 or 10 thousandths off the top in the face mill. I touched off, I did my probe, or I just went into the work offset and I said, subtract 5 thousandths, make sure this all cleans up. Run around the outside of the part, make sure I don't hit the vise. And then when we flip it over, we're machining off that 1/8 inch on the backside. Yeah.
I missed something. You've got a lot more depth that the vise is hanging on to this.
Yes. So this ended up being 12 millimeters, 472. And I said I'm going to pick 5/8 material. 4 inches wide, 5/8 thick. And then we're going to buy bar stock and cut it off to 4 3/4. Right. So that becomes my stock size. I'm holding on pretty much minimum to be this aggressive, and holding on by 80 or 90 thousandths, but I'm trusting the tool and I'm trusting the setup. I'm also trusting that I can close the doors and that the part won't come flying through. The other side of it is we go up to the 3/4 inch material, and I have a full 3/16 to hold on to. And I would say even at 3/4, 4 inches wide, if I really lean on this vise, I'm going to be able to move this part. I'm going to be able to bow this part. Leaning on the vise 80, 90 foot-pounds on the vise screw, I'm going to be able to bow this part 2.5 to 4 thousandths in aluminum. Steel, okay, maybe a thou or two, but aluminum, yeah. So when we do the demo, one of the reasons that all my machines that I carry torque wrenches around with me, that all my machines have torque wrenches, is they all have the same. First part has the same amount of squeeze as the last part. And if I don't like the holding, I can go up 5 foot-pounds, or I can go down 5 foot-pounds, and I'm staying in the same range.
Would you ever consider like drilling a small hole through one of those, just to put a bolt down in and
Sure.
latch onto something to keep it?
That's the fixture, yeah. We need a dedicated fixture. The other side of this is, do we want to, plasma is a little ugly. Do we want to not really set up to wire? We would have to have all those holes. Plasma would blast through. Water jet would blast through. So do we want to set up a full sheet and rough these out, and then have a fixture that comes in and locates and cleans up? Because at least then we're putting as big a piece of material on the water jet or on the plasma, and it's going to run 70 or 80 of these, and maybe the kerf or the overrun or whatever fails 1 or 2 of them. All right, is that an acceptable loss? Maybe. For the 100-piece run, that initial conversation, that would be something that comes up, is what's the fixturing required, and can, just like the gang milling, can I build a fixture that I can have my operator set 10 of these down, clamp them in place, walk away for 10 minutes instead of 1 minute, not have to tend it, go do some deburr, go do some surface prep, those kinds of things. All right, so getting into the material. Let's see, we're not really doing anything. I'm saying that this roughing pass is going to not leave any, we're not going to leave any, not going to engage compensation for stock. And that one aggressive, I'm going to leave 10 thousandths of material. And we just added subtracted 30 thousandths from the depth. So I'm not going to leave any stock on the floor. Now that also does require that after I take that facing cut, that I'm going to go back and put a pair of calipers and check the depth of what I'm telling that end mill to go, and maybe it's more like 10 thousandths of cleanup, but I'll at least start with 30. And then lead in, Again, how much am I imagining that I have stock over here? 20 to 30 thousandths in this direction and maybe 60 in this direction. Then 50 thousandths and 50 thousandths with a 90 comes down on the part, ramps in. Would like this to be just a little bit bigger. We'll see what it looks like. So 100 thousandths, and pretty much what that's doing is the radius of the tool plus what I put in here, plus what it's going to add to the arc on the end of that. So we'll see it. So go ahead and accept it. And it started at the midpoint, which if we start midway on any part, we're going to end up with a blemish line. You're going to see a parting line that is there. So so the red is my rapid down, slower feed into the arc. If this does happen to contact material or is in material up to that point, it's at least a little gentler to get into the part, runs around, comes back, ramps out, lifts, and goes. All right, so we need to get that onto a different corner. Going to edit, go back into the operations and look. We have an entry position. And so my entry position, I really wanted it over here more as a matter of course. And I don't see where we told it midpoint, but we did. If I get it to start on that corner, then I really don't need 90 degree at all.
Where the face mill, that was just the closest point where the face mill was?
Could be. I wouldn't always say that because it makes some really goofy decisions sometimes. All right, so I turn the 90 degrees off, and that becomes a little stranger, but down, in, and around. All right, so I was looking to have those come off of the corners, but I may not have given it enough. Okay, I'm just going to increase those so we can see them a little bit better. All right, so really that's not too bad. We're outside of the run and comes around. All right, so it goes into the corner and we have 10 thousandths. All right, so I have the choice of drawing a sketch if I want to run completely around. But looking at this, I should be able to pick my way around to the corners, have that end mill that ends here, pick up over here on the climb cut, and end over here with the finish. All right, if I do that as a sketch, then I only have one sketch to pick. So we'll do it both ways. Let's go ahead and make sure that that got saved. I want this same operation, so I'm not going to start a new operation unless I can't duplicate what is already generated. So when I duplicate, I get the same tool, I get the same operations, or the same operation parameters, and then we're going to go in and clear selections. I'm going to take that propagate along Z off, and then I'm going to select, 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 and the arrows are still showing up okay. And if this was more complicated with lots of small little pieces of geometry, I would go in back over to the SolidWorks side, open up a sketch on that face, and darn it, I did it again. I know better than that. I am at the top of the part, not at the bottom of the part. All right, so let's just use this as an example. The preferred would have been to select the bottom, and then I would draw my sketch on this one, and I'd have to change the sketch plane anyway. All right, so things that you do in the background because you don't do them all the time. All right, so that one picks the side. Now the difference here is that I went from contour and told it to go another 30 thousandths. Well, here I almost want to go to from selection. So we can enter value, hard code values from top, model bottom, stock top, stock bottom, contour, selection, and absolute from the origin. Well, the origin is at the bottom of the part, so that might be one. And here, if I were to tell it to go to the model bottom, that shifts it down as well. So if I can pick it, and then it's going to continue to go 30 thousandths past. So different ways to approach the logic. I would say just be consistent. The one that you are used to, or the ones that you want to make the selection. And so I would prefer to select across the bottom rather than having different strategies from part to part. This one goes to aware, which is going to initiate the G41, G42 for compensation. It's set for tool center line, so the diameter of the tool is 0. If I need to make this part a little bit smaller, I tell it that the end mill is a thou and a half minus 0.002 in the diameter control, and it brings it over that much and makes the part come into tolerance. And no stock to leave. Lead-ins should be okay with the clearance. I didn't see if it knocked everything out, but we didn't simulate. So chances are I left a nub. Is it okay to have a projectile? Not really. Is the 4-inch face gutter going to care? Probably not. Am I going to have a bunch of little tabs in the bottom? Probably. All right, so those are questions that we want to make sure that we have answers before of, is this going to be small enough? And what I'm looking for, let's just go ahead and jump into the simulation. Stock simulation all, and we'll go ahead and slow it down. Let's see, one of these, tool shaft, tool, shaft, not so much. Tool holder's already off. Face. Okay, we can go a little faster than that. It's kind of a small nub. And the corners, those are going to be stuck. I mean, those are also potential projectiles. So finish pass and out. All right, so far I'm good. That's a little bit of a concern. Maybe not so bad. New operation. Okay, so I'm basically starting with the holes. I could duplicate again, but I don't want to get too far into the contour with the settings. All right, so I'm good with those numbers. My selections then, I'm going to go back to my strategy of the bottoms. And what I want to look for is the occasional arrow that jumps to the outside. That would be a bad thing. And we're just going to since we're going to ramp these in. Oh, and I meant to do that on the other operation too, so we can set it here. 0.1, 0.1, and for safety, I'm going to leave that at 0 while I do this. All right, so I picked those as my numbers. 1 inch as the clearance, 0.1 as my retract and feed height. And let's see, if I right-click and say Make Default, and then Make All Default, those are now my defaults. So you find numbers you like for clearances, you find numbers you like, right-click in this, and Make All Default takes everything in that property manager and makes it the default. So it'll take a couple of times, a couple of programs to, yeah, I like that, or I need to tweak that a little bit, get it to working the way that you want. We're going to stay with the minus 0.03. And mainly the 10 to 30 thousandths is so that when the face mill comes across, we'll have a little bit of burr, but we're not going to have a piece of really thin aluminum foil stuck in the end of each of those holes that we have to pop out. And then we'll go ahead and initiate wear. And not worried about depths, not worried about stock. So all of those look pretty good. Allow rapid retract coming out of the holes. There's nothing in the bottom of the geometry to keep the tool down, so not worried about that. Lead in, lead out, fairly small. A lot of times on the contour I'll default that to 5 thousandths rather than 50 thousandths. Keep it really close and then step it out, especially for the bores where half-inch tool is really close. So I want to go to a ramp. The ramp will be the greater, or the lesser of the two numbers. If I tell it that this can be 20 degrees, but we're at 472 50 thousandths on the step down. Let's see. All right, so maximum ramp step down. would be 10 passes. Well, I think 20 degrees would probably do that in 2 passes. So my max would be 200 thousandths. So it'll calculate, is 20 degrees greater than the 0.2, or is 0.2 the greater, and it'll take the lesser of the two numbers. Not sure I said that right. We'll see it in the helix. All right, 0.1. If everything else touched off okay, I'm going to bring this down just a little bit closer, and we'll accept. All right. So spiral ramps in, takes one pass around, retracts out. If I decide, now one of the things is because this is blowing out all of that material and removing it, then let's go back and see if I can find it. We're going to repeat the finish pass. So it hits the bottom, and instead of stopping, it goes around one more time before it does the retract. I'm okay with that. Alright, so that contour ended over here. It jumped to that hole. The other thing would be to, if I wanted to preserve the order, let's get back into the edit. Lost it. Where did you go? Okay, preserve order. That should be the order that I selected. Since it started here, I now expect it to come over here. So pick, 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 pick. To make that change, to make that adjustment, since I can't really reorder these, I'd have to remove them and select them in a different order. Okay, not a big deal, but I'm not that concerned about it. The jump from here to here versus here to here on a rapid, I don't know. We could argue that one, I guess. All right, so we've blown that material out. New operation is going to be back into the contour. And library tool by type, flat end mill, 1/4 inch, and select. 10,000 RPM at 60 inches a minute. Probably not. The 10,000 RPM I'm not so worried about. What's that? Oh. The 60 inches per minute, yeah, going into that corner, I'm expecting that to be aggressive. The 1/2 inch tool I would expect can handle it. Oh, I made it worse. I went to 5,000, so I was going to go to 1/2 thou. 15 inches a minute. All right, I'm thinking 15 inches is still a little on the aggressive side, but manageable. The selection, we'll go tangent propagation. Wrong direction. I'm inside of the part. All right, and I can tell that if I'm climbing going that way, then I want to reverse. And if you can identify that on the first selection after we turn the propagate log Z off, then that will save having to search for it on the others. All right, the other thing is if we were just going to run this face and this face, then we would have individual control as opposed to setting up this chain and having it that arrow pretty much affect all of the selection. All right, so contour, I made it my default. I'm at 0.9, I'm at 0.1. It might have come over just because we had it selected, but we'll go ahead and stay with the -0.3. How about 0.03? And we'll go ahead and turn the wear on. Nothing really there. Stock to leave is off. And again, we're going to leave slightly larger numbers, and that can go to 0 because we're just going to have it step in, come straight in. And I'll go ahead and give it another 0.1 there. No need to ramp. It's going to go in, come out. All right, so let's see. Get back to my view. All right, so this is still going to be a little bit of a heavy cut going into the corner, but I may find that I have to slow it down to 10. Maybe it'll take 15. All right, and a little bit of a jog there, kind of off to the side. Not worried about it. It's looking for clearances. All right, so we make sure we save it. Facing operation could be used again. So we flip this over, we put it on the same work offset. It's now shifted over by however much material I told it to take off. So if I told it touch off on this edge of the material at the work stop and take 60 thousandths of material, I now shifted the part over 60 thousandths. So is that a big deal? Probably not. I could post this out from the same face. If it needed to be a second operation, I would have a machine orientation 2, maybe. Or for the view, or we go ahead and set up a new job. And the face is now there. Oh, it didn't stay. So I'm going to have to Z-axis. Reverse. No, I don't think that was a reverse. Oh, I haven't set the x-axis yet. So pick. X-axis looks okay. Selected point. Go to the corner. Program name 2. P1-8. Setup 2. And the work offset can stay at the same G54. So the question is, taking that 1/8 inch of material, do I need to put the 1/2 inch tool back in and rough off 1/8, or will my facing tool take care of it? If the facing tool will take care of it, then we're just going to duplicate, and I'm going to drag that operation from one job to the next. The orientation is wrong, the selection is wrong, but when we go through and make the edit, it finds the new stock, has the same parameters, still set to stock contours in the new orientation, and okay with those numbers, okay with the lead. Go ahead and accept. And the critical question is, are my arrows going the correct direction? Because if they're pointing down coming from the other way, I got a little bit of a problem. All right, as long as this is coming in, making the cut. Now 200 thousandths for the clearance plane, I got to think about that, because I have about 1/8 of an inch. I have somewhere between 90 thousandths and 1/8 of an inch of material that we're going to blast off with this 4-inch facing mill. Do I have enough clearance that if the overhang is kind of in this area, is it going to be coming down in material and then ramping in, or do I have enough clearance to be clear of the part and come in on that face? All right, that's another one of those. We go to 5% on the rapid in overrides, and we walk it in kind of slow and make sure that the first article that we get a good part. All right, so except for the little islands in the corner and the little island in the middle, I'm fairly confident we can run this and get a good part out of it. So let me go ahead and save this, and we will take questions.